So this video is going to be very short because the difference between simple linear regression and multiple linear regression is not that great. When we left off in the last video, we had a model built. We were comparing the amount of time that the students studied to their exam score, and we had all that we needed. We had verified that the data were good enough, and we had all that we needed to build our model. Now what we would like to do is we would like to add in another variable, and the other variable that we'd like to add that could also help us kind of understand what would impact the exam score could be exam anxiety. So we'll go ahead and put that into our input variables. These are both our predictor variables, and now they work together in tandem to help us make a better prediction. This is the whole power of multiple linear regression. Multiple linear regression uses multiple inputs, and the idea is that we get a more exact and a more precise output. But what does it do to our results? We're not going to change anything else here. We're just going to add anxiety as a second input. We are now looking at, remember there's 5 things we want to look at. In simple linear regression, we want to look at the R squared. If you remember from the previous model, the R squared was a little lower than this. It was about 16. Now it's up to 20.9. But we're not going to look at this one anyway. What we're going to look at is we're going to look at adjusted R squared. We look at R squared when there's a single input variable. We look at adjusted R squared when there's multiple input variables because it takes into account the interaction and the combination of those multiple variables when it's determining how much of the variability in the exam score these two can account for in tandem. Okay, and we're still better off. We actually have an adjusted R square of just over 19 when our previous one was around 15.7, I believe. We'll look at our F statistic and our p-value, and those both look fine. We know that our variables are able to predict some of the variability in the exam score, and we know that that's going to make us much better off than if we just use the mean. Here's where things get a little different. We have now an intercept. As I indicated in the previous video, we will always have one intercept. That intercept is quite different. That score is quite a bit different. So we're starting at 87. I think the previous one was around 40. And then we have 2 predictor variables. So now we have to use both of these predictor variables. We have to use this to determine the slope. So we do that in combination. What we do is we start with intercept, and so we say that our predicted value is going to be the intercept, and to that intercept we add our x value. Say for example it was 10 hours of studying, so we add the x value times 0.241. We put that in parentheses, we calculate that out, it would be 2.41 whatever, and we set that aside. We actually are going to add that to the intercept. Then we're going to try to account for anxiety at the same time. And maybe the anxiety factor is calculated at, say, 0.7 or 70 or whatever the variable is. We're going to take that input variable of anxiety, we're going to multiply it by its slope, which in this case is negative 4.485. We'll do the math on that and we'll set that aside. So now we have 3 values. We have the intercept, we have the combination of revise and its slope, and we have the combination of anxiety and its slope. Those are 3 values, and we add them all together, and that becomes our predicted output, our y value, our sort of what we're assuming the exam score is going to be. So that's how we account for when we have multiple inputs. Each one has its own slope. We never really do nothing with the intercept, but we calculate the x value input by its slope, times its slope. We calculate the other x value input by multiplying by its slope, and just add the 3 up, and that's how we get to our final result.